Right now you're pretty much right in the middle of Module 4, Data Quality. Last time I talked about levels of measurement. Remember N-O-I-R, nominal, ordinal, interval, ratio. Nominal and ordinal, categorical. Nominal is just basic categories. Ordinals are categories that you can rank. Interval and ratio are numeric. Interval you can put on a numeric scale and you can do addition and subtraction. Ratio you can actually do multiplication and division. Remember when I told you about all the metadata things that you should have present? Down at the very bottom there's something called accuracy and precision. So I need to talk a little bit about those terms and what they mean. Accuracy is how close a measurement compares to the true value. Precision is how close repeated measurements compare to each other. Not necessarily to the true value, but to each other. So there's kind of an older definition that went kind of like this graphically. Here we have a target, and the center of the bullseye we'll assume is the true value, and someone has taken 4 shots at that target. And you can see that in this case all 4 shots are pretty close to the center of the target. So that would be accurate shooting. All 4 shots are also pretty close to each other. So that would be high precision. So this is a high precision, high accurate shot. In the second example, all 4 shots are far away from the center. So that's going to have low accuracy. But all 4 shots are close to each other, so they have high precision. So this is a low accuracy, high precision example. And in this example up here, the 4 shots aren't really very close to each other, so they're low precision. But the 4 shots, kind of on average, are considered to be close to the center of the bullseye. And so that would be considered high accuracy. So you can see where this older definition is going to have a problem, because when I compare this one, which is supposedly high accuracy, to this one, which is also supposedly high accuracy, I think I would say that this one in the lower right-hand corner is much more accurate than the one in the upper left-hand corner. So a newer definition might deal with that problem. Sure enough, we have a newer definition. It's ISO 5725-1. That stands for International Standards Organization. So the people who think about this and talk about it and know about it have come up with a standard that better reflects the concepts of how close something is to the true value and how close repeated measurements are to each other. So in the new definition we have accuracy and precision still, but we introduce something called trueness. So we didn't have trueness before, but we have it now. What the heck is trueness? It's how close a mean or average of measurements is to the true value. Kind of like what we thought of as accuracy before is maybe trueness now. Precision is the same. It's how close repeated measurements are to each other. So in order for something to be accurate according to the new definition, it has to have both trueness and precision. Okay, trueness plus precision equals accuracy. Here's that same graphic as before. So before it was high accuracy, high precision, everything's okay. In the new definition, it's high trueness. So trueness again is the mean of those values. It's close to the center, high precision, so that's equal to high accuracy. It has both high trueness and high precision, so it's high accuracy. Second example, this one has high precision, close to each other. The mean or the average of these points is not close to the center of the bullseye, so it's got low accuracy. Low accuracy, high precision, what's that going to be? Low accuracy, because the trueness now is low. Okay, third example. The old definition said it's got high accuracy, kind of the mean is close to the center, but it has low precision. In the old definition it has high accuracy. In the new definition, it's got high trueness because the average is close to the center, but it has low precision. So in order to be accurate, something has to have both trueness and precision. So in the new definition, it has low accuracy. In the old definition, high accuracy. New definition, low accuracy. So that's the one that's different between the old definition and the new definition. This one kind of reinforces the same concept as before. We're looking at accuracy versus precision in the old definition, but now we're going to change things to trueness versus precision. Okay? What do we have? Upper left corner, average is close, true, not very precise. Upper right corner, it's precise, but the average isn't close, so it's not true. Lower left corner, it's not really very precise and not very true. Lower right hand corner, it's both true and precise. So accuracy in the new definition requires both trueness and precision. So in the new definition, not accurate, not accurate, not accurate, accurate. Okay, next time I'm going to start talking about data quality and errors and how you try to characterize or quantify data quality and error magnitudes.